Next question is 2.47. Neon gas is generally used in signboards. If it emits strongly at 6.616 nanometer, calculate. 4 questions are given. First is frequency of the emission. Second is distance traveled by the radiation in 30 seconds. Then third one is energy of the quantum. And fourth one is number of quanta present if it produces 2 joules of energy. So your entire question is divided into 4 parts and we're going to solve each of them to find your answer. So here it says the only value given to us is wavelength. So here lambda is equal to 616 nanometer. That's the only thing that's given to us. Now here the first question, let's solve one by one. It says frequency of emission. So from lambda you're going to find out what is frequency. So write on the first one that for frequency, the symbol for frequency is nu. Nu is equal to c by lambda. Now c is velocity of light. So the value of c is 3 into 10 to the power 8 meter per second. Now since c value is in terms of meter, nanometer should also be in terms of meter. So this is equal to 616 into 10 to the power minus 9 meters. So now you have the value of c, you have the value of lambda. We will just substitute it here. So c is 3 into 10 to the power 8 meter per second by lambda value is going to be 616 into 10 to the power minus 9 meters. When we simplify this one, you will get 0.004870 into 10 to the power minus 9 goes up, it will become plus 9. So 8 plus 9, that will give you 10 to the power 17. Meter and meter will get cancelled. So your unit is seconds inverse. Shift your decimal here till significant number and you'll get 4.870 into 10 to the power 14 seconds inverse. This is going to be the answer for the first question that says frequency of emission. Now the next one is distance traveled by this radiation in 30 seconds. So here the second part of the question is to find the distance traveled in 30 seconds. Now we know that here in this case when you talk about distance you will talk about speed, right? So when you talk about speed, speed is equal to distance by time. That is the formula you have, right? So in this what you're supposed to find out is distance. Okay, and so since we are finding out distance, d is equal to speed into time. But in this case speed is not given to us, but speed can be taken as the velocity of light, the speed of the velocity of light. So because speed is talking about velocity, so in this case since we're talking with respect to wavelength and everything, we can consider velocity of light instead of speed. So here distance is going to be taken as, instead of speed I am taking velocity into time. Velocity of light is what? 3 into 10 to the power 8 meter per second into time is given as 30 seconds in the question. So 30 seconds. Seconds and seconds inverse will get cancelled. 3 into 30 will be 90 into 10 to the power 8 meter. This is going to be the distance that is travelled by this particular radiation in 30 seconds. So that answers our second question. Now the third one is energy of quanta. Energy, we know the formula, E is equal to h nu. We can just take h nu because nu value you just found out. So substitute that value. H is nothing but Planck's constant. So 6.626 10 to the power minus 34 joule second into frequency here is taken as 4.870 into 10 to the power 14 seconds inverse. Seconds inverse and seconds will get cancelled. 6.626 into 4.870 is 32.268 into minus 34 plus 14 will be 10 to the power minus 20 joule. Shift a decimal over here, this will become 3.22 6.68 into 10 to the power minus 19 joules. This is going to be the energy of quanta, which is the third question. Now the next one is the last question. Number of quanta present if it produces 2 joules of energy. So what you found out here is the energy of one quanta, because it says energy of quantum, basically of one quanta. So here we can say that energy produced by one quanta is this much. 3.2268 into 10 to the power minus 19 joules. Therefore, X quanta, energy produced by X quanta equals how much? 2 joules of energy. So for 2 joules you have to find out what is the value. So when you cross multiply, X is equal to what? 1 into 2 joules divided by that value, which is 3.226 into 10 to the power minus 90. When you substitute all of this, joules and joules will get cancelled. You will get 0.6199 into 10 to the power minus 19 will become plus 19 quanta. Okay, when you shift your decimal here, this will be 6.199 10 to the power 18 quanta. So this is your answer for the last one.